Hey, welcome everybody. Jim Warren with TXAPA. Glad to have you all here today. We are coming to you remotely. We don't have our studio in operation right now due to some COVID issues. Hopefully we'll get that sorted out here shortly. But we are certainly glad to have you guys here with us today. We're starting a brand new program, Asphalt Pavement Fundamentals, and we're going to be spending this spring even into the summer talking about asphalt fundamentals. So we've got a lot of stuff to cover and a short amount of time to do that. So we're trying to tighten these programs up a little bit, not go too long. So asphalt pavement fundamentals, man. Chuck, come on in here. Oh, you're already in here. Good
I'm
afternoon.
in
How you
here.
doing, buddy?
I am doing good sitting in my 900 square foot house in my one chair. If you guys hear any kind of ruckus, it's because I got an 85-pound dog that's running around here and he's controlling the roost. But my wife promised me that she was going to curtail him, which we'll see how that works. Okay.
Yeah,
So,
just got to get him a whole bunch of new tennis balls. He'll be in good shape. He'll
yeah.
be in good shape. Hey, so Chuck, let's talk about this whole thing about asphalt fundamentals. What do fundamentals mean to you, and why are they important?
Yeah, so we got to get back to the basics on everything. I remember as a kid, my dad telling me that, and when you're working on an engine, you need only two things. You need gas or fuel, and you need a spark, and that's all you need, right? Boiling it down just to the very basics. And every time I remember that, I go back to the fact that even though this is a very complex a process and very complex, very analytical. I mean, we got people with PhDs that design and build roadways,
Mm-hmm.
but there's the basics. There's the very basics, and I think that this series that we're going to go through is going to cover the basics to where we get it back to a point that if we don't have fuel and we don't have a spark, we're going to have issues. So let's get to the basics. I'm going to spend about 30 or 40 minutes on each one of these over a period, like you said, over the next 8 to 9 months. But it's a pretty good little series. We're not going to delve into the weeds. Okay,
Okay.
that's the main thing. We're not gonna jump into the weeds. And so what we're gonna do is hit the highlights and hit the basics. So we're gonna start off with aggregate. So with that being said, the definition of asphalt pavement, it's pretty basic, everyone. This is pretty simple to do. It's just a mixture of liquid asphalt binders and graded aggregates mixed at an elevated temperature and compacted to a uniform pavement layer density. So what we have is essentially we have aggregate and we have binder, liquid binder. Sounds pretty simple, just like the gas and the spark. But we got components. So let's talk about our components that we're going to do. We have our binder, right? The liquid asphalt binder. We have aggregates and we have air. That's it. That's all asphalt pavement is liquid asphalt binders, aggregates, and air. And it's pretty simple, right? It
We
can
make it
get
more
very
complex than that, don't we?
it does, but it's that simple. So when we start having issues, what do? We break it down to the basics, and that's what we're going to talk about. So with that being said, we do have other things that can be involved. We do have other things that we can add to it, additives. I am not having any kind of control over my screen whatsoever.
Hmm. Well, you were doing good.
I don't know what's going on here. I have no control over it.
You can't advance?
There it goes. Maybe try doing that. We
There
do
you go.
have modifiers. We do have other modifiers that we can add. We got binder modifiers, which are rubbers, elastomerics. We can add lime, which is again on the aggregate side, and you can add warm mix. Okay, those are some of the modifiers. But today, what we're going to do is we're going to talk about aggregate. Okay, that's all we're going to talk about is aggregate. So let's look at the components. Let's look at the aggregate itself. If you notice here, we have the aggregate, we have the liquid binder that's covering the aggregate, and then we have air voids. Why do we have air voids?
You asking me?
Anybody know why we have air voids?
I do. I do.
There we
We,
go.
We need some room for that mix to further densify over its lifetime, don't we?
Yes, we definitely need the air voids for it to be flexible. And also, I was reminded that we have to have air for an engine to work also. So you have to have fuel, you have to have spark, and you have to have air. So thank you,
There we
buddy.
go.
I appreciate that. But it does boil down to the fact that air is a component. It definitely is a component. It's a very important component. But I want everybody to remember this slide when we get into some of the components of aggregate. The main reason I want you to remember this slide is because think about what the aggregate looks like right here. Okay. So let's think about the components all the way from the top. Again, we have 85 to 90% of it's going to be aggregate. We're going to have some liquid asphalt, 3 to 8%. We have air, and we have a little bit of absorption. But most of the
You're talking
components.
volume now, not weight, right?
That's correct. That is
Right. Now
correct.
you're talking about volumes, not weight. Yep.
That is correct. That's exactly right. It's about volumes on this. And so it's very, very, very simple, but it's very easy to mess up. But let's get to the very basics of it. And again, we're going to talk about aggregates, which is 85 to 95% of the mixture. Okay, aggregate considerations. We need to use good, clean materials for good performance. We need to properly sample. We need historical data. And this is something that I find kind of strange, but it's not. It's consistency over quality.
Mm-hmm.
And when I say consistency, we need our aggregate source to be consistent. We need it to have the same characteristics each time. And the
Yep.
reason that we need that is because of the fact that all the quarries have variables, right? Especially in Central Texas or limestone quarries.
Nature is anything but uniform.
That's correct. So at the beginning of this thing, we saw a quarry shot, and that quarry shot shows the different types of material that are involved in that shot. And so being a quarry operator or being a quarry manager, it's more of there is science to it, but it's more of an art. And that art is trying to blend those aggregates together to get the most consistent material possible. That's our goal, is to get the most consistent material possible going through an asphalt plant or even a concrete plant. We're going to say the word concrete one time here. They both use aggregates, but it has to be consistent. And the consistency is going to affect different things within our process here. It's going to definitely affect our test results. It's going to affect the way that the asphalt plant operates. It's definitely going to affect our in-place densities. And what does it affect the most? Pay. It affects our pay. If we have inconsistent aggregates coming in from behind the asphalt plant, we're going to have inconsistent mix going out, and we're going to be chasing. That's the whole thing about it. It's about chasing the material, whether it's coarse or whether it's fine, whether we have an absorption issue or a clay issue. So we're always constantly having to check that, and of course quality. The main thing about this consistency is that the more consistent we're at the asphalt plant, the better our quality is throughout the whole process. And it is a process.
You just answered my question before I even said it. Yep.
Yeah, it is definitely a process, and we're concentrating on quality. Now, with that being said, how do we do this? We do it through tests.
Hey, before you go on to that one, Chuck, let me just ask one question. How does sampling affect consistency?
Yeah, that's the whole game right there, is that you have to consistently sample correctly. It has to be sampled correctly. And we'll get into stockpiles and looking at the way that a stockpile is built, and then the way that a stockpile segregates. But if we do not sample correctly, we are definitely not going to get consistent on our test results. So our aggregate test results are so important. So what we have with our aggregates is we have a consensus property. What that means is that paving experts all over the world agree on certain things that the aggregate has to have, okay, for it to be able to perform. We have to have coarse aggregate angularity. Okay, remember that slide back there that you looked at? Those aggregates were interlocked together, right?
Mm-hmm.
They need to be interlocked. So if we don't have that interlocking mechanism, that's the coarse aggregate angularity. That's an interlocking mechanism. We also need to have fine aggregate angularity because we got to fill the voids also with something. You just can't fill the voids with oil, right? You're going to have different types of aggregates, different sizes of aggregates, and they have to be able to interlock together. They have to be able to have that interlock together. Sand equivalent. Sand equivalent tells you how much particles that you have in it, whether it's clay particles or dust particles that you have in the material. And we're going to talk about that a little bit later on here. But sand equivalence is a consensus property, and it's an aggregate consensus property. And then flat and elongated particles. Why do we not want flat and elongated particles, Jim?
All kinds of reasons. Number one, because they break and they start changing shape. So, I mean, you get a long flat piece that you think it's a 1/2 inch material and it breaks, and now it's a 1/4 inch material, and it just starts changing all your volumetrics up in a big way.
Absolutely. And it's not going to interlock with the other aggregates around it. So it's
No.
very important that we don't have flat and elongated aggregates. The other tests that we look at are called source properties. Now, source properties or values are from specific sources, and they're not reached by consensus. In other words, these are going to be values, or these are going to be test values that we're going to have that each agency has different values for them. So it depends on your pavement needs, on whether or not you need a very, very durable or a very tough rock, or if you need a very, very dense rock. So what we have is our toughness, which is LA Abrasion and Micro-Deval. Those are our toughness tests. Those are our degradation tests. We have sodium soundness. That's how dense that material is, how that material is going to react. And then we have deleterious materials, which is all sorts of foreign additives. You know, we could have wood, and we could have a blasting wire. We can have plastics that come from the blast. I've seen that quite a bit. Blasting wire and plastics come from a blast. You know, then that's deleterious material. That's going to have an effect on our aggregates. So we need to make sure that we have good, clean, sound aggregates for them to be able to act properly. So with that being said, aggregate properties related to pavement performance, okay? What do we have here? We have gradation, we have particle size, we have durability, we have toughness, frictional characteristics, cleanliness, we have moisture susceptibility, and we have absorption. These are all the aggregate properties that are going to be relating to pavement performance. That's pavement performance that's going to happen out in the field. Well, with each one of these, what do we have? We have a test that's going to be able to determine this, right? We have a test that's going to be run on each one of these properties. So our gradation and size, we have a sieve analysis test. It's very important that we maintain our stockpiles and our aggregates behind the asphalt plants in the correct sieve sizes, okay? We have, because whatever you put in an asphalt plant is going to come out. So it's very important that our gradation and our sizes are known through sieve analysis. And we need to run these quality control tests on the materials that are behind the asphalt plant. Okay. I do know that they run sieve sizes and gradations at the quarry, but most of the time, I want to know what's behind my asphalt plant. So we want to know what's in our stockpiles behind our asphalt plant.
Yep.
Now we got particle shape. So we talked about, you know, coarse aggregate angularity and fine aggregate angularity. And then we also have fractionated or elongated materials or rocks. Again, very, very important. We need to have those particle sizes be able to interlock together. We need those particle sizes to work together. Again, when we have an issue, we have a mat or a mix that looks like it's tender or it's walking or it's crawling. Most of the time I can go back, I can look at one of these tests and say, hey, we're out of spec or we're out of range on this. And that's the reason why that material is not acting properly. Anytime you have a material that acts badly, we go back to the basics and figure out what is happening at the very beginning. What is happening with my properties at the very beginning? Durability. We got soundness and we got Micro-Deval. that's a durability. Again, the Micro-Deval is a degradation test.
Mm-hmm.
We have toughness tests. We got our LA Abrasion. LA Abrasion is an impact test. It's going to tell us how that aggregate's going to respond to a ball bearing hitting it. And I'll show you that test here in a second. But those are our durability tests and toughness tests. We got frictional characteristic test. That's our polish value. And that polish value reverts back to a skid history. And what we're trying to do is have lower our wet weather accidents on our roadways by having our aggregates that polish less. And again, I'll show you some of those coming up here, Jim, in a second. But just because an aggregate is very durable and it's got good skid value and it's got the coarse aggregate angularity, and it still might not work correctly in a mix design if you don't get those particle sizes to interlock together.
Okay.
So cleanliness, we got sand equivalent and methylene blue. Methylene blue's not a new test, but in Texas, we started really looking at the methylene blue. So the sand equivalent's going to tell you, your dust sizes or your sizes that are in the material. Methylene blue is going to tell you how they're going to react, how these clay particles and how these dust particles react. So there's a lot of studies, a lot of work has been done with methylene blue over the last year. And what we're finding out is that we have some bad characters out there. We have some material that has a clay line or clay particles in it that act very poorly with liquid asphalts. So very important test along with the sand equivalent. We have absorption test, of course, to determine how much that aggregate's absorbing. And then we got the classifications of aggregates. So we have the TxDOT Bituminous rated source, and this is on the TxDOT's website. It's underneath the materials producer list. It's going to tell you your surface aggregate classification. That's what SAC means, of the aggregate sources of all the quarries that are in Texas. So they go through, and every 6 months they run these different tests. They run LA Abrasion, the soundness test, and they determine what surface aggregate classification each of these quarries can produce. Mm-hmm. And what that does is that we have two sources, or we have two types. We have surface aggregate classification. We have a SAC A or a Class A, and then we have a Class B. Okay, so those are the two surface aggregate classifications that we have for Texas. And again, it's run through the materials and test, but they do it every 6 months. So they're updating this catalog. And again, what they're looking for is very, very consistent is what they're looking for, material that's consistently within these parameters. So if you go around the state, what we found out is that all sandstones will meet that Class A rock. Okay. In other words, they're going to work well in all your surface mixes. That's your SAC A. It's got high skid values, very durable. And of course, it's a sandstone. Your limestones and dolomites, only one meets the Class A. So all your limestones are all SAC B or Class B rock. And again, it's not saying that it's bad. It's just giving it a classification that TxDOT has come up with. Gravels, 77% of all the gravel quarries meet that Class A. And then the igneous rocks, your granites, all of those will meet a Class A. And of course, all your lightweights will meet a Class A. And again, it's about polishing. It's about that aggregate polishing during, while it's being driven on by cars, whether or not it becomes slick or not. So, but just because, again, that it's a SAC A doesn't mean that it's going to automatically guarantee skid resistance, okay? You have to look at the full picture. You have to look at everything. But that's the reasoning for having this surface classification, is because of skid. We're trying to, again, build our roadways to where they don't polish and they're resistant to acid rain and polishing, to where we don't create a skid issue or skid problem. So,
well, let me ask you a question, Chuck, on that whole SAC A, SAC B stuff. How much, since you said the only one of the limestones really make a SAC A, what's a predominant material in Texas?
Yeah, limestone.
So, I mean, the reality of it is we don't have an unlimited supply of sake material. And so we've got to use the right product in the right place. And if you're trying to get skid resistance, does it make sense to put a sake underneath?
Good point. Those are good points.
Yeah.
Absolutely.
I mean, those are I think as designers, we've got a lot of DOT people on today, TxDOT people and other people. You can get a guy from Oklahoma. Thanks, Kevin. You know, we got to make sure we use the right material in the right place so we conserve the materials that we've got. So just remember that when you're looking at these designs and looking at plans, and you know, if someone's got SAC A in the intermediate or the base layer, there needs to be a really good reason for that. So otherwise, we're just throwing that material away.
Yeah, you got a good point. And again, it's surface aggregate classification. So that's a good point, Jim. We want this material to be on the surface. We want it to be, you know, on that riding surface to where our again, that's where you're looking for that. That's where you're looking for that skid resistance. So that's a great point. We are limited on our sake, and as everybody knows that that sake is also utilized by the seal coat industry. So our seal coaters are utilizing sake quite a bit also. So you're absolutely right. We are limited in our material source, and we really should pay attention to exactly where everything's going and where it's at. But that's a great point. Glad you brought that up. Also, another thing, Jim, just because it's sake doesn't mean that you're going to be guaranteed skid resistance, okay? Even though the slide here says to guaranteed skid resistance, we have seen some mixes designed with sake rock that do not perform well with skid resistance. And again, it's that whole thought process of putting the right rocks in the right place. So, you know, that's a lot of good points. Micro-Deval. So Micro-Deval, again, is a degradation, resistance to degradation. We're putting in these 3/8 inch ball bearings in some water, and we're running it on this little device here. And what it does, you can see as the aggregate goes through that cycle, it actually becomes more round. You know, that Micro-Deval actually becomes, makes the material become more round through abrasive force, okay? So that's an abrasive section. The LA is it shows how much the aggregate degrades in resistance to impact. So these steel ball bearings in here, these guys are 2 inches in diameter, and they got a little paddle up here. And what happens is that paddle and these things run around, and it shows how much this aggregate breaks down. What they do is the test procedure calls you to screen it over a number 12 sieve to see how far it breaks down. And what that, again, it's durability and it's resistance to degradation. So those two tests right there are very important for our aggregates, you know, to be able to see how durable. You know, if this 2 inch ball bearing here beating that aggregate down, if we have a huge loss here, we don't want that aggregate in our roadways. There's no reason to have that aggregate in our roadways. So again, all the quarries go through this process. They get tested, and again, to determine that, those values are on that catalog. We got sand equivalent, methylene blue, very simple test, very easy to run. Again, we're over here at the sand equivalent. We're looking at the amount of fines that are in that sample. The methylene blue is going to tell us how bad those fines react, you know, to or the clay fines, I should say, have a reaction to. So methylene blue and sand equivalents are very important tests to be able to utilize on our fine aggregates. And again, these are aggregates. We're utilizing, you know, everything's an aggregate. A lot of people don't realize it also, and we'll get into this a little bit later on in the series, but a bag house, your bag house is bringing in the fine aggregates back into your mix. So that's another aggregate source. So again, we got aggregate, liquid asphalt, and air. And the bag house is an aggregate source. So
if anybody has any questions, go ahead and type them in as we go. Go ahead.
We got consistency. Again, the whole thing about this municipality considerations is consistency. And when I say we have to be consistent here, we have to be for us to be successful. And quality control, QC, is so important. And all those tests that we just went through, a QC guy out there at the asphalt plant can run those tests and know what we're dealing with, as material is coming in. So very few asphalt plants are in the middle of the quarry. Most of the asphalt plants have a limited space, foot space, and so they're always bringing new material in. As they're using, they're bringing new material in, and it's real important to have a quality control plan in place to know what aggregates you're dealing with. I can't stress that enough. Just because you get it from a certain source all the time doesn't mean it's the same material. You got to pay attention to it.
Got a comment come in, says RAP is an aggregate source too, Chuck.
Absolutely. RAP is an aggregate source also, and it should be treated as your most expensive aggregate source out there. We need to crush it. We need to stockpile it. We need to know the gradation of it. We need to separate it. We need to have fine aggregate and coarse aggregate and RAP also. We need to follow the same exact procedures as you would at a quarry with RAP. And if we did that and treated it as our most expensive commodity on our asphalt plants, we would have some really, really good high-performing RAP. Again, RAP is definitely an aggregate source. It's definitely needs to be treated as your most expensive aggregate source. I believe it. That's the way we used to treat it, and it worked for us. But you can see here, there's a dime, and you can see how clean and angular this aggregate is. You can see there's no clay balls. There's nothing involved in it. It's very clean, very durable looking, very uniform looking. That's what we want to see. That's what we want to see. Either 80 or 95% crushed faces or 100% crushed faces. Again, that's going to give us that angular ability for that rock to interlock together when they're putting the designs together. All right, stockpiling and storing. We got to have good stockpiling procedures. It's crucial to producing asphalt. If the material in the stockpile is segregated or contaminated, your material coming out of the asphalt plant will be contaminated and will have segregation issues. Yep. So we talk about segregation quite a bit. We got mechanical segregation, and then you also have thermal segregation. But most of the time when we start talking about mechanical segregation or we're having issues with it's all about the material being stockpiled at the asphalt plant and how it's being utilized in the mix design. So
and how it's being handled in between. Yes, sir.
Absolutely. And coarse aggregate piles segregate easier than fine aggregate. Anybody know why? Coarse aggregate piles will segregate easier than fine aggregate. If you've been in a sand pit or anywhere else, that coarse aggregate will roll to the outside. As they're making the stockpiles and as they're building them and as they're loading them, that coarse rock will run to the outside. So it's real important to pay attention to your stockpiling and storing of aggregate. We need to use clean, well-drained surfaces for stockpiling aggregates. Okay, maintain proper gradation with stockpiles by, again, keeping the stockpiles apart. We don't want contamination between stockpiles. Use a bulkhead between stockpiles, and then the bulkhead should extend the full length of that stockpile. If you don't have a good footprint to separate them, you need to put a bulkhead or something to separate them. And then storing aggregates in bins. That's another method of utilizing good practices at your stockpiling of your aggregates. Okay, handling. Angularity of the aggregate, again, is one of the most important portions of producing a good hot mix. Each time the aggregate is moved or stockpiled, the aggregate degrades and the edges become rounded. That's a pretty important statement right there. If we're moving stockpiles, once it gets made at the quarry, then you load it up in a truck, and then you come over and then you dump it, and then your loader is maneuvering around the stockpiles. You're constantly degrading that stockpile. You're constantly having that aggregate become degraded. So it's really important. The handle should be at a minimum. So, and I do know this, and I've seen it also. I've seen it to where we move stockpiles back and forth, and it just gets to where it's completely out of gradation. And again, that's where your testing, your sieve analysis come into play. And that's how it's usually handled, is through, again, quality control at the asphalt plant. Here, real quick, basics, pave underneath the stockpile area. That's going to help you prevent you from getting that loader dug into the mud or what have you. That's if it's not on a paved surface, pave that stockpile area. Bring in the material from the front, load it from the back, or vice versa. Always do the same procedure when you're bringing in material and when you're using your loader. Slope the stockpile for drainage. This is a good slope. There's some sand being stockpiled here. Again, slope the stockpile. And again, we talked about the bulkheads. If your footprint doesn't allow it, we need to separate these with bulkheads, some type of devices to keep these materials from going into each other. And again, contamination can happen here just as easy as it can happen anywhere else. Very important to have that. And again, you can see these sloped areas. Everything's sloped. Again, here's our coarse aggregate.
Hey, Chuck, on the bulkheads, the bulkheads are not meant to add more storage in there, because if you overrun the bulkhead, then you're going to contaminate the pile next to it. So that's another good sign there. Just to make sure those are below whatever bulkhead or bin height extensions that are in the stockpiles. Even in the bins in the asphalt plant.
That's a good point. Yeah, putting a bulkhead up doesn't give you the opportunity to overload it to where they still become contaminated. That's a great point. But yeah, we want to treat our stockpiles again. You treat them, keep them uniform. Keep them to where the loader, the height of the loader. You don't want to run up on top of the stockpile. We just talked about the loader handling it. Every time a loader, bucket, or wheel or anything touches, it's going to degrade that material even further. So it's real important that you have good stockpiling practices and a good loader operator at your asphalt plant and paying attention to all that, Jim. That's exactly right. Looking at here, this is limestone material. This is the components of a type D dog. And you can see that we have some coarse aggregate, then we have some intermediate aggregate, then we have some fine aggregate. And in the fine aggregate, again, you can see how uniform it is. You can see the dime. There's no clay balls. There's nothing that indicates that this is going to give us any kind of issue. But it's real important to pay attention to your stockpiles. If your stockpile, after your loader bucket comes out and stockpile is standing straight up and down, you have some clay in there. You want to check that. You want to make sure that you don't have the bad clay, the methylene blue bad stuff in there. But anyway, again, very uniform. You can see the angularity. And when we combine these aggregates, we're going to combine them in a structure during the mix design. And what we're doing is we're combining to gain structure with the aggregate. And that's real important. And again, it's through sieve analysis that you can do this and be able to create a real good, durable mix design. Again, if we do everything correctly, Jim, this is what it looks like. It's great material here. This is a PFC that was laid, and again, the aggregate structure is there. It's going to be durable, long-lasting, and it's a great when it comes out. When it comes out good, it's great. When it doesn't, we're in trouble. But again, if you do have a tender mix, you have a mix that's not acting properly, or we got a poor acting mix, the very first thing I go back to is I go back to that aggregate, make sure that my aggregate is consistent with what I designed with, and I work backwards. Then I'll work with the oil, and then I'll see what's going on with that, and then I'll look at temperatures. So there's different processes to go through, and we'll talk about that as we go on through our fundamentals. But again, with the aggregate, look at the angularity, look at the cleanliness, make sure we don't have that clay that's in there. Make sure that we have the consistency. Make sure that we are utilizing the aggregate that we designed with. That's very important, And again, once we start seeing a bad actor out there, start with the aggregates and work backwards. And I think that you'll be able to find your problems pretty easily once you go backwards. And again, at TXAPA, we approach the issues. We're dedicated to quality. We're partners in quality. We really and truly preach this, we live this, and it's all based on commitment, communication, and cooperation. And that's about it on the aggregates end. Next month, we'll concentrate on the liquid end. We'll concentrate on the liquid asphalt end on next month. And with that being said, Jim, you could do whatever you'd like to do with me now. We have any questions? We have anything else? We definitely
Any more questions you want to come in? Go ahead and put them in the box. And you know, a good basic understanding there, Chuck. Good approach. We need to remember these things as we're going through it. Again, you know, what percentage of the mix is made out of aggregate? You know, by weights, 94, 95%. By volume, 85+%. So it is the major contributor to pavement performance is the aggregate. And I think, you know, just because it's a big bulk volume, that doesn't mean we don't have control over it. I mean, the contractor's doing his job. They're testing materials as they're coming in the stockpile. They're charting where the material is. They know what's in the pile. They can make adjustments, small, fine adjustments as the material varies. And we know the material is going to vary because the stuff out of the quarry is going to vary. And
Right.
so it, like you said, it's a management thing of being able to say, okay, well, my fines are shifting a little bit, my course is shifting a little bit. I've got to make a little adjustment so when it goes to the asphalt plant, the final product is meets this particular requirement. And so I've got to be able to continually adjust that a little bit. So if you're working around an asphalt plant, you're going to see them making fine adjustments, and as they're going along, that means they're doing their job. If they
Absolutely.
just turn on the plant and never do anything, that would concern me greatly, because I don't think anybody's got that good aggregate. And I've got a lot of good aggregate members. We appreciate your support, but the reality of it is it's a naturally occurring material and it's going to vary some, and we all
Right.
know that. And some materials vary a little bit more than others. And you know, what we found over the years is sometimes contractors, in order to make a certain type of mix, may end up having to use a certain type of aggregate just because it's more consistent. We know some mixes are, I call them a little bit more technical than others, like our PFCs, our SMAs. They can't handle big swings in material variability and still meet all the requirements of the mix properties coming out of the asphalt plant. So you may see different people using different things depending on the type of mix that they're using. So good stuff today. Anybody, if there's any other questions, go ahead and send them in. But you know, we're right about 45 minutes, and we're trying to keep these things a little bit shorter. Had 58 people on board today. That's great. We appreciate everybody on board. If you have any questions or anything, you can send me an email, jwarren@texasasphalt.org. And I'll get them on the Chuck. And if you have any other ideas or want us to cover any other topics, please let us know. But I think that's going to wrap it up for today. Again, trying to keep things under sort here. And apologize. Thanks for working with us as we kind of worked out our mobile operation today. We appreciate the patience and helping us do that. So Chuck, big thanks to you. Big thanks to Wink. Give him another tennis ball for being quiet today. And thank you for participating. We look forward to seeing you next time. And we'll be off next week because of letting. But then we'll be back the following week. Look for announcements coming out, and we'll look forward to seeing you soon. So in the meantime, keep washing your hands, wear your mask when you got to. Be safe out there, and ever forward, everybody. Take care.